All right. Hi, everyone. We are at a Q&A with Brendan, Dolan, Gavitt. I hope I'm not butchering the name.
Perfectly well.
In reference to our work with GitLab AI Assist, as well as FullPilot, and anything to do with smart, secure code suggestions. So I'm going to first start off with actually just probably saying what Brendan would say in his own words, who he is. Brendan is an assistant professor in computer science and engineering department at NYU. He holds a PhD in computer science from Georgia Tech and a BA in math and computer science from Wesleyan University. His research focuses on software and system securities, most recently the security of large language models, trained on code, and how such models can be used to improve security. He can also be found posting pictures of cats and making very bad jokes on Twitter at, I will let Brendan leave how you say that.
Sure, this is just Moyex. This is one of these things where you chose a username in high school and it's been with you ever since. So yeah, thank you very much for the introduction.
Perfect. We're super excited to have you. We within GitLab, we have the product and engineering as well as our incubation engineering team with a whole lot of questions as it's there in the Google Doc. We can first probably start just kick off in just a rough giving in your words what is FullPilot?
Sure. Yeah. So I guess FullPilot kind of came about because so I had been using GitHub CoPilot and thought it was, very helpful in doing my own programming. But I guess as a researcher, we wanted, my lab wanted a way to be able to do things like, if we train our own model or fine tune our own model for different purposes, we'll want some way to actually, use that in something that looks like a GitHub Copilot kind of use case. And at the same time, I guess, whenever I saw people discussing, things like Copilot online, one of the things that they were sort of concerned about is this, the fact that you have to sort of send your code up to some remote server hosted by GitHub to actually get suggestions, right? Because it sends sort of the code that you're currently working on and maybe code that's working that is in other files open in your editor so that it can get code suggestions. And there was a lot of interest in being able to kind of run your own locally hosted version of it. And around, I think this was sometime in maybe January or February, Salesforce released these fairly high quality code models that were open in the sense that you could actually download them and run them locally yourself. And they had reported, at least, that in their evaluation, some of the models, like the 16 billion parameter Python model, had comparable or better performance on sort of standard code benchmarks like human eval or apps for solving programming tasks. So yeah, that was essentially it. So a lot of the research I'm doing these days focuses on like, okay, here are these code models. It seems like a lot of people are going to be using them over the next few years. I think I saw a stat the other day that GitHub Copilot got 400,000 new users in their first month, which that's a lot of people suddenly using, AI code suggestions. And so we want to do research on, how can we make sure that the suggestions that it produces don't make your code worse? And ideally, can they suggest things that are sort of more secure than what you might be inclined to write by hand? And questions like this. So I guess I see it as kind of a combination of, this is our research platform for, running future studies. We've already done one kind of user study where we gave half of the users access to the code model and half of the users wrote things by hand. And we didn't use FullPilot for that one because we ran it before FullPilot existed. But we're planning on doing more of those in the future, and we are going to try and use those with FullPilot because that really gives us very kind of fine-grained control over we know the exact model that they used. We know what it was trained on. We can use models that were fine-tuned on particular code bases, or only trained on code that we've maybe tried to scan for security vulnerabilities or things like that. So yeah, that was kind of the main thing. I guess I also don't want to necessarily oversell it. It is a project that I kind of put together over the course of maybe a month or two over the summer when I was, not didn't have to teach. And the main components are, from other more mature projects. So NVIDIA's Triton Inference Server and the Faster Transformer library are what we're using to get this kind of very nice low latency inference. And I guess that's the main thing. So yeah, hopefully that is kind of clarifies how this thing came to be.
Absolutely. I think that says a lot. I know this probably helps us with even the second question, but Fred, I think that was your question on what was inspired to build FullPilot, and did you have anything more on it, Fred?
No, it fully answered my question. Thank you so much.
Yeah.
Cool.
So if we want, we can keep going through the questions.
Perfect. I think next was actually Fred again.
Okay. Oh, yeah. So maybe wait for him to step back in front of the screen.
Yeah. We can come back into that as well. We can skip to probably 5, which would be my question, and we've spoken about it, but I think we are looking into building out of a POC using FullPilot. So what would you think we would need to consider in actually using FullPilot and testing it with let's say even internally with our GitLab audience of developers, with writing in different languages, with ROR, Vue.js, Python, and all of that. And also keeping in mind compute, storing, how do we actually go about it? So any advice on that?
Yeah, I mean, so I think some of the things you've already kind of mentioned in your question, like load balancing and batching, I think will probably be pretty important. Batching is a little bit tricky because you sort of have to have enough people using it that it makes sense to combine multiple requests, because if you have to wait, 30 seconds for the next request to come in before you try to batch them together, then all of a sudden your latency is 30 seconds for that first user. But assuming you have a lot of requests coming in simultaneously, then batching together makes a lot of sense. You do, you almost for free get kind of higher throughput without really hurting latency, as long as the batch fits in GPU memory alongside the model. Let's see, other things that would make sense to do. So load balancing is definitely useful, and I think that that's something that you can do pretty trivially by just running multiple servers and having either a front-end proxy that redirects to one of them, or by changing the little Flask app to redirect one of the inference servers. Either of those should work pretty well. The models don't have to really store any state, right? They're all kind of one shot. You give them the context and then they produce the suggestion. So there's not anything where, like, if a user was making multiple requests, they would always have to go to the same server. So it's really a very nice use case for load balancing there. Going beyond that and starting to think about, what can be done to make things faster and more performant, and hopefully have lower resource requirements. There are quite a lot now of papers and even open implementations of things like, instead of using 16-bit floating point numbers to do all these computations, let's just use 8-bit integers. And surprisingly, for many of these models, you can actually convert them to 8-bit integers and just do the same inference, and you don't lose any sort of quality of the output, but it runs faster and uses less memory. And very, very recently, like 3 days ago, one group even managed to get int4, so forking. And so at that point, you're where you can run the 16 billion parameter model in just 8 gigs of GPU memory, right? Because 4-bit int means you're only storing 4 bits per parameter, half a byte. And so that can potentially really, could really speed things up. So yeah, so I think there are lots of, ways to make this even faster and use fewer resources. As things stand right now, for a given model, if it's a 16 billion parameter model, you need basically 16 gigabytes of GPU memory just to store the model.
Yeah. Thanks for that, Brendan. I think Fred is back. We just skipped your question, Fred, if you wanted to take up on number 4.
Yeah, sorry about that. Yeah, I was wondering if you have some metrics into insights, because there are quite a number of stars and people interacting with issues and pull requests. But I was wondering, do you have any insight, like how many times the image gets pulled, for example?
Yeah, so I don't know if I can do, I think I can do screen sharing. And I can just show you the traffic page, both for the GitHub repository, but also for the Hugging Face. That is the wrong one. Sorry. I think it's this one. There we go. So this is the page on Hugging Face where the actual models that it downloads are stored. And this is a pretty decent proxy for whether people are actually using it. Because, when you launch the setup script, it goes and downloads a model to use. And so, they're not enormous numbers, but people do seem to be using this. So the 16 billion parameter model has had about 600 downloads. The 6 billion parameter one is 101. And then I think probably people who are just trying it out might be using the really small models. So we get some downloads there for the Python only version and the multilingual version. And so that's a pretty decent proxy for whether people are actually using it. Almost no one is using the natural language versions of these because I think they're not even exposed in the setup script. And there aren't very many people who are trying to use FullPilot to help them write English. Over on the traffic page, so this, it's always a little bit annoying that GitHub only gives you the last month of usage stats here. But it looks like it's settled into around 100-ish clones per month. And then, more people than that, at least sort of checking it out and having a look at it. So yeah, I think that's about as much as I can say for sure about what the current usage is. It is definitely in the order of, 100-ish users a month as opposed to, thousands or anything like that.
Great, thank you. Thank you so very much for sharing.
So a quick question while you're on Hugging Face. My job as a product manager is speaking with our customers I've not run into any customer that uses Hugging Face today. I suspect that's largely due to enterprise use cases, but what's your take on Hugging Face?
So, I think I'm mostly using Hugging Face right now because they have been kind enough to let me host, let's see, something like 40, 80, basically like many hundreds of gigabytes of stored models with them for free. So that was kind of very attractive. As far as like what I think of them as a company, I like a lot of the things they do. They have made it a lot easier to train models and to host a bunch of fairly different models for inference. Yeah, so I guess I'm a little bit still confused by if they're a company, how they are planning to make money, but that's I guess that is their problem rather than mine.
Okay, you're right there with my same questions too.
Yeah, I think that plausibly what they're doing is something like, they have a bunch of people who know a lot about AI and building and training models, and they may be doing a sort of contracting thing where they say, oh, you can hire us to, help you train or deploy some model that you have or are interested in having. And they may be able to, make their money off of that. But yeah, I mean, it must be costing them quite a lot to host just for bandwidth and things like that to host these giant models. So I don't really know how they do all that.
Cool. We move on. I think then it would be back to me and Alexander. The models. We would love to know a little bit more on actually the models. Obviously, we have 4, so all the way to the 32 gigabyte one. Some more insight as to where the model works, which in what areas it wouldn't. And then I think Alexander had a few more questions just on how we would go in if we had to take that model and optimize it. What would that look like? So yeah.
Sure. So right now, the ones that are available are the basically there are 4 sizes and 2 flavors. So the sizes range from the 350 million parameter model, which is honestly not very good. The code suggestions it gives are pretty bad. All the way up through 2 billion, 6 billion, and 16 billion parameters. And I think I misspoke earlier when I said that would take just 16 gigs of RAM. It would actually be 32 gigs because it's 16-bit floats. But the 2 flavors are the multilingual one, which I believe was trained on C, Python, Java, let's see, Go, Ruby, and one other that I can't remember, but a reasonable set of popular languages. And the other one was then sort of further, so it was trained on all of those initially, and then it was further trained on a larger data set of Python code. So if you happen to be using Python, you definitely want to go with the Python only model, which is the mono flavor. So, I think the other thing, the other models that could easily be added, I noticed that the Faster Transformer library recently added a model called GPT Neo X. And there is a large model called, what is the name of it? It was trained by someone at CMU, and I can find it really quick. But that one was trained, I think, on a larger set of languages, and uses GPT-NeoX. And so that might be another one that could easily be added, because again, it uses Faster Transformer. You can convert their model into Faster Transformer and use it. And so that one might be a good one to add in the very near future. Beyond that, there are, of course, lots of models that are available on Hugging Face and can be used from within Hugging Face. And Faster Transformer has Triton has a sort of Python backend that you can run any model that you can run from Python, that would let you then run any of those models as well. Those would include things like Facebook has this one called Encoder. Hugging Face itself has one called CodeParrot, which is focused on Python. And they're current. What's that? Yeah, Polycoder is the one. Yeah, Polycoder is the GPT-NeoX one, and it is going, and I think that would be like half a day or something like that to add that to FullPilot as it is. And Hugging Face is also gearing up right now to train another large open code model that they're calling Big Code. Yeah. And I have been working a bit with them on that, just, on questions like, what kind of training data, what sort of model, and things like that. So that one I think is probably not going to be released for a couple more months, but when it is, that would be a very nice one to be able to add as well, in particular because that's going to support some things that are really useful for actually using this in an IDE. So it's going to be able to do things like this fill in the middle task, where you give the model not just the code up to the cursor, but the code before and after the cursor, and then ask it what the best way to fill in code in between is. And that's really helpful, just because a lot of times, if you're editing a file, you're not sort of writing it from scratch top down, you're making changes to what's already there, and the changes you're adding have to be consistent with what comes before and what comes after. Yeah, so I guess, are there other things that people wanted to know about the languages and models?
No, I think that's good. I'm good for now on that. I think Alexander, you're next with the questions on the model.
Yeah, thanks for the meeting. Yeah, the question is like that. So I saw to get recommendations, we need to provide several, let's say, hyperparameters. One of them is temperature, another one is max tokens. So I guess, so the question is like, is there a way maybe to tune automatically these hyperparameters for each project, or how should we set up them?
Yeah, I mean, so right now this is very much a kind of, more art than science. People have been mostly going by kind of rule of thumb. We want sort of low temperatures for code generation. So I don't know that there are exact ways to derive this. I have mostly not found that it is something that I've wanted to be able to change kind of on a per project basis. But I think it would be something that you might want to say, take some kind of standard benchmark and do a bunch of generations at different temperatures to decide on at least what the default is. And there are, benchmarks available, certainly for Python, and I think a few other languages for just, they're sort of smallish little programming problems that could be used for evaluation, and you just basically generate code and then run a bunch of tests to see if the code worked. As far as number of tokens, so the way that GitHub CoPilot does it is they mostly, so they always ask for a fixed 512 tokens. And the reason that this doesn't take ages to generate is that they change the stop sequence. So a stop sequence just says, as you're generating, if you see this in the output, then you're done generating and you can return immediately. And so the way they do it is most of the time it operates in a kind of one line at a time mode, where the stop sequence is just a new line. So as you're typing an individual line, maybe it only has to generate like 4 tokens to be able to complete that line. And then I think if you sort of stop and wait a little bit, it will then kick into this, oh, maybe we should try to generate a larger amount of code mode, where it sets the stop sequence to something that looks like, an end of a function or end of an if statement or something like that, which is more language specific. And then we'll try to generate that whole block of code. So yeah, and I think certainly that makes a lot of sense, particularly in terms of performance, because at least much of the benefit that I get from CoPilot is these sort of one-line completions as I'm typing, and you want those to be very, very fast so that you can even see them, like as you type one character at a time, it will go through different completions. And so I think that does tend to work quite well. If you are just trying to generate one line, it really, that does end up being, I think less than 10 tokens usually.
I think, Alexander, you have the next
one. I have also my question, the next one. Yeah. So what are the requirements for inputs to get recommendations? Should it be, I don't know, a good block of English, Chinese, or another language, or we can simply just pass, let's say, the Python code block and it will be completed, or something else?
Yeah, so generally speaking, you just pass it the code you already have. And if users want to kind of instruct it in English, the way you do it is by just writing a comment. And I have actually found this, it may be a little bit surprising, is that a lot of my code is much better commented now, because I write a comment saying what I want the model to fill in. And then it fills in based on that comment. So yeah, that's the usual scenario. It's not, I think that it is not very good with languages other than English in terms of comments. And again, just because there's not nearly as much non-English comment data in the data set. So if that is something that you wanted to support more, that would probably involve doing some fine tuning on the models.
Yeah, thanks. So I
is
guess
it fair to also say basically it fills in based on writing the beginning and not necessarily if it's in the middle?
Right. And so I think the main limitation here is that there's the model supports 2048 tokens a time, and that includes the input plus whatever it needs to generate. And so that means if you are asking it to generate up to 512 tokens, then that gives you around 1,500 tokens of input. And so often, particularly in a larger source code file, you're not going to be able to fit the whole thing into the context window. And so, the simplest strategy is you just give it the most recent 1,500 tokens. You can get more sophisticated about this because sometimes there might be extra context that you want to include. So, you could do something like, say, assuming that you know a little bit about what the language they're using is, you can like go up to the top of the file and look for import statements, and then have the prompt be, here's my import statements, and then here's as much of the code I can fit, so that it has things like library definitions or structs or things like that. And then you can even extend this by saying, oh, okay, you know, I'm writing C and they include foo.h. I'll go to foo.h and try to pull in some, you know, structure or function definitions from that file and cram them into this prompt. But again, you know, you're limited on space. And so all of these things, you do have to kind of try and balance how much context you want to be able to provide with how much space you have.
So I just got another question. Did you try, or maybe you have any ideas of using dependencies along with the piece of source code that as an input?
Right. I mean, so I think this is something that for now I have not done very much on kind of the client side. So this would all be sort of done within like a, you know, a Visual Studio Code plugin or an IDE plugin. And I have not done very much with that. I know that the GitHub CoPilot plugin does do a lot of this because I see it pulling in pieces of other libraries and other files that I have open. Yeah, so that is something that they're definitely doing. You know, it's a decent bit of kind of implementation work, particularly if you want to support a bunch of languages, because you have to know that like, oh, okay, in PHP it's require, and in Python it's import, and in C it's include, and then have to, you know where to find these dependencies.
I guess I have another question also, Mom.
Yeah, you
Yeah.
do.
Let me ask you. So how was the model tested? I mean, maybe several use cases were collected just to understand in which cases the model performs better or worse. Let's say, I don't know, unit test generation or web service or something else.
Right. So right now, tests are a wish list item, but as far as kind of evaluating like the quality of the model output, the paper that Salesforce released, which is called a conversational model of program synthesis, or conversational for program synthesis. What they did actually kind of a full evaluation of all of these, and on a bunch of benchmarks. And so that's kind of what I've been relying on for my general sense of which model should I use. And sort of unsurprisingly, it is that you should use the biggest model that you have, or that you can feasibly run. And if there is a version of it that is trained on your specific language, then you should use that one in preference to one that tries to support many languages at once. Aside from that, I guess just sort of using it interactively, I've found that it's pretty decent. It's much better with Python than it is with like writing C code, for example. And so I think this makes sense just given how much Python code there is out there. But yeah, I think it would be really nice to have like some, automated harnesses for saying, okay, I mean, even just, does the model still work to generate code at all? Can we run it on, a small benchmark and make sure we haven't kind of regressed on the quality of recommendations?
Cool. I think
Yes, sometimes it's possible that the source code is not compiled, right?
Right. Yeah, absolutely possible for it to produce suggestions that don't compile because, for example, maybe it refers to a variable that doesn't actually exist in your program. Generally speaking, it's not going to make the kinds of mistakes like forgetting a semicolon or, doing something obviously syntactically wrong. The mistakes really are more of well, it doesn't have any context, so it doesn't know what, the field name of this data structure is, so it'll just make one up. And sometimes it guesses right, and sometimes it guesses wrong. But that's, where this kind of sort of prompt engineering comes in, where you try to figure out, okay, what do I need to show it so that it can give me reasonable suggestions.
Cool. I think on that also, I'm also conscious of time, so we're gonna go through the questions of people who are also not in call. Dinesh, similar to the testing, how would you compare the usefulness of FullPilot suggestion with respect to CoPilot ones?
Yep. So I think certainly CoPilot is currently better at producing code. Some of that comes from the fact that I think they are using larger model. It might be using a larger model, but they're certainly using one that's trained on more data. So I think that they have trained it on basically all the code they could get their hands on. And as a result, it is pretty good at generating suggestions there. The other piece that it does better at is at this kind of fill in the middle task, because it does support being able to consider things both above and below the current cursor. That said, I think it has been sort of perfectly fine for kind of writing the kind of code that I usually write, which is like, okay, I'm in Python. I want to like read in a bunch of data from somewhere, do some like analysis on it, create some visualizations and graphs. That's the kind of stuff I do most often, and it works very well for that. And so I guess, I unfortunately don't do lots of stuff in like writing web apps in JavaScript or things like that. So I have less kind of direct experience.
Yeah, thank you for that. Dinesh is not in call, has other questions. Is FullPilot able to adapt its suggestions to the current project? What does it accept as input in order to achieve this? I think we sort of went through this already.
Yeah, so I mean, there's sort of two ways you could think about this. One is, what do you put into the prompt to generate the output? And maybe this is covered in a different question, but I think the other strategy is you could take a model and try to do, what's called fine tuning, where you train it on additional data for, a much shorter amount of time, and with a lower what's called learning rate, which just controls how dramatic the changes to the model are at each training step. And so fine-tuning these models is also possible, which is something that is not possible with CoPilot, because you need to have the actual weight of the model available to do fine-tuning. And the weights for Codex and CoPilot are not available. That said, fine-tuning is not totally trivial. It is not that hard, particularly because Hugging Face actually has made things fairly easy. You really just make a data set of your code in JSON form, where it's just a JSON dictionary, where the text keys is the contents of your source code file, and then each line is a new JSON dictionary. And then you can pass that to a standard script they have, and it will fine-tune the model on the code you gave it. The reason that it's not completely trivial is that this requires a lot of resources, particularly for the largest models. The largest ones that we have personally been able to fine-tune here at NYU are these, tune the 16 billion parameter model on a data set of Verilog code, which is used for like CPU design and hardware design. And that was a 400 meg code data set. And it took 3 A100 GPUs, each with 80 gigabytes of VRAM, about 6 days to do fine tuning on that data set. So yeah, the computational requirements are definitely not like I can take, my souped up gaming desktop and fine tune a big model on it. Fine tuning at this point is still something that you need kind of sort of fairly big servers for.
Yeah. I think that actually even answers the next question on how feasible it is to fine tune. So thank you for that. And then now, Taylor.
So I'm a bit curious on your perspective on just the market in general. So we've got GitHub CoPilot, you've got Tab 9, you've got Kite. We've done a pretty deep investigation of Tab 9. We like a lot of what they're doing, allowing you to train on just your code. Kite kind of seems to be falling out too. So I'm just curious your thoughts on the industry in general.
Yeah, I mean, so I think that it is only going to get bigger. The other one that is available now is this Amazon Code Whisperer, which is yet another, which I've not even had a chance to play with at all yet. So I've just, read a blog post about it. But and we do actually know the Tab 9 folks pretty well. We've been talking a lot with them about, collaborating on some things like, user studies with their users and figuring out, if there are ways that we can say, if we've trained like a model that tries to produce more secure code, can we try having it deployed with them to see if, it helps their users as well. That said, I have not personally actually used Tab 9, so I don't know as much about how it compares in terms of code quality. I do think that their approach has been to use much smaller models and then try to kind of make up for that by training on your own code and using language-specific models. So I think they have a smaller model, but that's been trained, specifically on Java, and another one that's been trained on Python, and another one that's been trained on C. And that's sort of how they get around that. But anecdotally, I sort of have heard that the quality of output it gives you is not up to what CoPilot currently does. And I can believe that because the Codex model is very, very good. So yeah, I definitely am not the person to ask about business questions because I know nothing about it. All I will say is it seems like it is going to be very, very popular over the next few years because when it works really, really well.
Awesome, thanks for that. On to the next question. And this is actually kind of funny as I was looking at the articles that I've been researching. You were actually referenced in a number of them. There's been a lot of research done on CoPilot and detection of, bad, insecure, malicious, verbatim code. What do we do about this?
Mm-hmm. Yeah, so this is a great question. So I've kind of gone back and forth on this. So initially we did this big evaluation of CoPilot on a whole bunch of different classes of vulnerabilities where we made these like little toy scenarios. Like I'm about to insert some data into a database. CoPilot, how would you do that? And it would say, oh, I will use string concatenation to put your SQL into this database. And that was obviously a very bad idea because that was an SQL injection vulnerability. And when we measured the rate at which it does that, in that study, it was something like 40% of the time, which was quite bad. And so that was quite alarming. But, then we sort of thought a little bit more and said, well, okay, but we don't know how often our human users would make that kind of mistake. And B, if it's being used by a human, then presumably they also have a chance to look at the output and say, oh, that doesn't make any sense, or, oh, that's obviously vulnerable, and fix it. So we actually did do a user study, and this paper we actually just submitted 2 days ago. So I'm happy to share a copy of that, but we did this user study comparing the functionality and security of code produced either by hand or with the assistance of Codex. And somewhat surprisingly to us, it did not seem to hurt security. So the two groups of users, and also this could be the users we chose, right? These were undergraduate and master's students in computer science, and they were writing in C, where it's very hard to write good code in the first place. But the rate of vulnerability between the two groups was basically the same as far as we could determine. And so that's maybe a little bit encouraging on the one hand, but also discouraging on the other hand. Encouraging because it means it's not making it much worse, but our kind of working hypothesis at the moment is that because the models were trained not to write good code, but to very accurately predict what would come next in a source code file, if the code that you write is not very secure or not very high quality, it will very faithfully write insecure and low quality code for you. And so it did tend to kind of match the quality of code written by the user that was using it. And obviously we would like it to do better than that, right? We would like, even if you have written some kind of bad code, for it to produce better code. So that's kind of my main ongoing research area. And we have a few kind of fun ideas for how to do this. One is that we can try to actually kind of patch these models. And there's a bunch of different ways you can think of doing that. So you could collect a new training data set and annotate it based on some judgment of its code quality, and then basically train it with a quality tag followed by the training data. And that would let the model have some idea of like, okay, this is how I produce like high quality code. And then when you are trying to generate user, like actual suggestions for a user, you would always include the high quality tag so that the model is strongly influenced to produce higher quality code, even if what's already there is not as good. So something like that could work. We've also been looking at ways of doing this without having to do any additional training. So there are some very, very, very recent approaches that will try to sort of directly edit things that the model knows by actually just like updating the floating point weights. And this works in natural language models to do things like changing facts. So the example they had in this paper called Rome was you say, the Eiffel Tower is located in, and then the model says Paris, and you want to update that so that it says it's in Rome. And they actually figured out a way to do that. And it then actually affects other things the model knows. You can say like what landmarks are near the Eiffel Tower, and it will say like the Colosseum and things like that. And so I'm currently working on trying to make that work in the context of code, where I'm hoping to be able to say things like the function you use for hashing passwords is, and then the model currently wants to say SHA-256, and that's not really correct. I want it to say bcrypt, which is what you use for hashing passwords and sort of other data. And so, but that again, like that is definitely research. That is not a product that can be deployed today. As far as kind of practical stuff you could deploy, things like, even just encouraging people to run existing sort of code scanning tools on their output. Unfortunately, I mean, the recommendations are mostly the same recommendations you would give for people who are writing code by hand. Like, you should test this. You should use security scanning tools. You should maybe try fuzzing your software. And I guess pessimistically, I expect that advice to be taken up about as well as it is for human written code.
Awesome, thanks.
Yeah.
I think we have a few more on few people. We're not on call, so but I think we've sort of covered that. So from Stefan, any other use cases where FullPilot? I think we covered the ideal situation where FullPilot works. Anything where it's absolutely would for sure will not work.
Yeah, I mean, so I think it definitely works very poorly for languages that are not well represented on GitHub. So it's awful at writing. We found it's awful at writing Verilog, which is why we ended up fine-tuning our model on Verilog. And I would expect this to extend to any other kind of languages that are, more niche or popular, including probably things like Haskell or, OCaml or what's the, other things in the Lisp family, which have just never become all that popular. And even kind of newer languages like Rust, where it is becoming very popular, but there's still just not nearly as much Rust code out there as there is Python code. So I would definitely expect it to do pretty badly on languages like those. I'm trying to think of other cases where it will definitely do very poorly. I think without additional kind of prompt engineering, it's going to do worse and worse the further you get down in your code, because as these long range dependencies get further and further away and are gone from the context, it's just not going to be able to know anything about them, right? Because it can only remember the last up to 2048 tokens. And so going beyond that, it's going to start to get it's just not going to know anything about anything outside of that.
Cool. I think we sort of covered that in 13 as well. If you can just even quickly, probably, I know we've talked about this, but if you can share with the audience what you think, where are we heading with computation, large scale models, deep speed quantization? Where are we going in it?
Yeah, I mean, so I'm actually very excited about where this has been going so far, because it seems like people keep finding ways to make these models use less and less memory and do inference faster and faster without seemingly harming the quality of the output at all. So it was sort of shocking to me that you could take a language model and compress it down to just using 4 bits per parameter without really hurting its performance. And I think that trend is probably, I mean, it has to stop somewhere, because, you can't use 0 bits per parameter. But I think that it will still be able to go down even a little bit further. So I think that's going to be really nice. So quantization is going to be a big area, and it's going to be, right now it's sort of only a few models have been quantized, but I think many more could be. And then as far as just plain speeding up inference, this is something we actually have a couple students looking at right now, and this is more just looking at can we do on the existing code to make it run faster on existing GPU architectures. That's going to be a little bit tough just because, for example, like Faster Transformer is written by someone at NVIDIA who presumably knows the NVIDIA graphics architecture really, really well. But we do think there are some opportunities for speeding things up even there. And we're also kind of looking at how do you speed up inference in the case where, you know, maybe you've got a data center with some fixed capacity, you've got lots of requests coming in, and, you know, at some point, maybe you start getting overloaded. And so, like, is there like a small reduction in quality you would be willing to sacrifice in favor of keeping inference time very low? And there's some kind of more, you know, advanced strategies you can start to deploy at that point. Like much of the time when you're doing inference, you don't even have to go all the way through the model before it's pretty clear what the next prediction is going to be. So you can sort of bail out halfway through that inference step and say, yep, it's the next token is like with 90% probability going to be this one. So just return that one instead. And that seems to work pretty well. So I think there's, you know, I think things are only going to get faster and cheaper and pretty quickly.
Yeah, agree. Thank you for that. I know, I think it's from both me, Taylor, and everyone. Thank you so much for the time, but we also want to know if you have questions first.
Oh, yeah, I'm trying to think. So, I mean, the main thing is really just, you know, are there things that you've found kind of about the way things are currently implemented that, you know, you say, oh gosh, you know, it would be much better if it were done this way. You know, this is clearly not something we could deploy because, you know, it's something that's fundamentally broken here or something like that. I know that Fred has been very kind in providing pull requests to help improve it in many ways so far. And I've been trying to make sure I give some attention to his code suggestions. But yeah, you know, are there things that, yeah, but basically, how can and I will caveat this by saying that I don't have tons of time, but are there ways that I can help make FullPilot better for the use cases that you have in mind?
I think you were right on the money with prompt engineering. I think that's going to be like the major differentiator, because I've been playing around with it, and it really greatly depends on what you give as the prompt, on what kind of return you're going to get that's actually meaningful. So I've been currently working on authentication, so because we don't want anyone to be using the compute that we're going to host. But I've also been working on the VS Code extension for the GitLab official workflow. I think that would be pretty awesome if we can like also kind of promote that within the project, that we can get contributions there. Because I think there are a lot of people with really clever ideas about prompt engineering. Because right now it's just the most simplistic thing there is. I think it just takes the last, I don't know how many tokens it takes, but it just gives it, and yeah, it's not optimal.
Yep.
Yeah, I think those are like the major points right now, at least what I'm seeing.
Yeah, no, I think that's a great idea, and I think you know, I've definitely wanted to be able to point users to an extension that works well, particularly with FullPilot, because right now there's some kind of, you know, you can hack up the GitHub CoPilot plugin in various ways to make it talk to FullPilot, but a lot of things might be a little bit broken, and it'd be really, really nice to be able to say, hey, look, here's a actual Visual Studio Code extension that you can install that will work with FullPilot specifically, and then I'd definitely be very happy to start, you know, asking for and hopefully contributing some ideas for how to make the kind of prompt engineering side better.
Yeah, it would be awesome. We released the first version of a VS Code extension that supports FullPilot this week. I think Tuesday it was.
Oh, wonderful. Okay, I would absolutely love to tell 17,000 followers on Twitter about that and, promote it on the project page. That's really cool.
That would be awesome. Yeah. Yeah, and I think we also discussed this, like CI/CD, that's probably something that's going to be quite crucial. So right now I'm hosting a fork on GitLab that does have CI/CD, but yeah, maybe we can have a follow-up conversation on that, on how to make that more publicly available.
Yeah, that I would be very happy to do that. And I may actually even be able to run some kind of CI/CD server, just because I think like GitHub Actions still doesn't support things like actually having like a GPU available. So we might be able to do some amount of CI/CD that's hosted on some machine that has a GPU, so that we can actually, do tests that involve generating suggestions in a reasonable amount of time.
Yeah, we can definitely do that with GitLab with our GPU enabled runners as well. So that's something we do support on it. So yeah, we can definitely send you the link and all for it as well. Yes, sorry, go ahead.
I said we already use GPU runners inside our team. Yeah.
Yeah. So yeah, so we could definitely help you with that as well. Yeah, for sure. But other than that, anything else, Brendan, we can support and help? Like, really, thank you so much for this.
Sure. Yeah. And I guess we're a little bit over time, so I don't want to keep everyone. But thanks very much. It's great to talk with folks, and I'm very excited to hopefully be able to make FullPilot a lot better and, have a lot more people actually being able to use it to help them code.
Yeah. Thank you so much for it. And before we actually go, in the notes, we also have the feature wish list for FullPilot. That was basically everything we can use to anyone wants to contribute into that. A whole lot of lists that Brendan actually put together for us. So thank you for that. And then, yeah, well, thank you everyone for the time, and thank you, Brendan.
All right. Thanks very much, and have a great day.
We'll be in touch.
Okay.
Thank you. Bye-bye.